Hello and welcome back to another video, guys. So today we will be learning another chapter of the IB Maths AA course, and that is partial fractions. So for the time being, we have given a break to the statistics part that included the probability and all those videos I have yet uploaded on my channel, and now we will be doing partial fractions. Okay, so first of all, let's understand the term fraction. Okay, so a fraction basically is what is a fraction? You may say that it is 4 over 5, 3 over 5, 7 over 5 probably. Okay, so in all these things, a fraction is basically when there is a part of a whole. Okay, so this is basically 4 parts of 5, which is a whole. Here it is 3 parts of 5, which is a whole. And this thing, you call this in earlier grades as a as an improper fraction. Okay, so what is meant by an improper fraction? An improper fraction is basically means improper to be called a fraction. To be called a fraction. Okay, what does that mean? That this 7 over 5 is not a fraction, but what a fraction is, we represented as mixed number, and that is 1 whole 2 over 5. Okay, so 1 whole 2 over 5 is a fraction, because this 2 over 5 is a fraction. Okay, and what does it mean when we write 1 whole and 2 over 5? This basically means 1 plus 2 over 5. We don't write the plus, but actually there is a plus over here, because when we convert this back into mixed number form, then we do it by taking an LCM, which is 1 times 5 plus 2 over 5. Okay, and then it comes 7 over 5. Okay, basically we multiply this part, or in mixed number form we multiply the whole with the denominator and then add the numerator. So basically we're taking an LCM where there is a plus in between, which we don't write. So that way this is an improper fraction, this 7 over 5. But a proper fraction, a fraction is basically 1 plus 2 over 5, and over here 2 over 5 is a fraction and 1 is a whole. Okay, so that is the basic concept of a fraction. A fraction is a part of a whole. Okay, so now let's understand what a partial fraction is. First, let me just write the definition. Part of a whole. Okay, so the definition of partial fraction is that what do we do when we have two fractions, like 1 over 2 plus 2 over 3. What we do is we take LCM, so it would be 3 plus 4 over 6. Okay, and that would be 7 over 6, and then we will convert it to mixed number, which would be 1 plus 1 over 6. Okay, which could also be represented as 1 whole 1 over 6. Okay, so that is how we add these fractions. But what if we have this 7 over 6 and then we have to represent it back in this form? So this is basically the concept of partial fractions, that when we have a fraction and we have to express it in its partial form. Now let me just make you understand this by a question. Okay, so let's say that we have a question over here that says, let me zoom in a bit. Okay, so a question, for example, could be 4 over 3x plus 5 plus 2 over x plus 2, let's just say. Okay, this first let's represent it in the one fraction form, like a single denominator. What would we do? We'll simply multiply the 2. We'll multiply x plus 2 with 4, and that would give us x 4 times x plus 2, and then we will add this thing, the product of 3x plus 5 and 2, which would give us 2 times 3x plus 5. Okay, and then in the denominator we would multiply the 2. Okay, so this would give us 3x plus 5 times x plus 2. Okay, so for the numerator we'll leave the denominator as it is, 3x plus 5 times x plus 2, and for the numerator we could simplify it as 4x plus 8 plus 6x plus 10, and then we could further simplify it as 10x plus 18 over 3x plus 5 into x plus 2. This is pretty simple, right? But what if we have this form, in our question, and we have to represent it in partial fractions form? So what do we do? So this is a typical partial fractions question. Okay, so let me just write it over here. The question is 10x plus 18 over 3x plus 5 into x plus 2. Okay, so we have to represent it in partial fractions form. Okay, we can then later check if our answer matches with this thing over here. That means that our working is correct. Okay, so for step 1, let me write it over here. Step 1 would be that we express it in factored form. We express it as two fractions. Okay, so what do I mean by it? Like let me just write the question again. 10x over plus 18, 3x plus 5, x plus 2. Okay, and now the step 1 is, what do we do when we have this form? When we have this form, this original form, we multiply out the denominators, right? We multiply the denominators with each other. That gives us 3x plus 5 times x plus 2. Okay, now we'll separate the denominators. Okay, so this time we'll just go in reverse order. We'll separate the denominators, and that would give us, let me just write it over here, 3x plus 5 plus x plus 2. Okay, so these are the two denominators that we have. For the numerators, we don't know yet what the numerator would be, because when we multiply all this out, then we get the numerator. So let's just write it a and b. So for step 1, we just write it in write the denominator as factors. I'll write denominator as factors. Okay, then we'll go on to the second step, and that is that we destroy the denominator. You can remember this by this alliteration of destroy, the D word, destroy the denominator. I don't mean any other D word. Okay. Okay, so we will have to destroy the denominator now. Okay, so what do I mean by destroying the denominator? Basically, we will simply multiply this over here, and that way we'll destroy this denominator. Okay, so let me just write it over here. 10x plus 18 is equal to a into 3x plus 5. So basically, as this are two terms on the right hand side, so both terms will be multiplied by this denominator. Okay, you can first, for simplicity, I could just write it first as 3x plus 5 into x plus 2. Okay, and this is being multiplied by a over 3x plus 5 plus b over x plus 2. Okay, so now we could write it in more elaborate form. Plus 18 is equal to, first let's multiply this thing with the first term. Okay, so when we multiply this, a over 3x plus 5 times 3x plus 5 x plus 2. Okay, and then we would have b over x plus 2, and that again we will multiply the entire thing, 3x plus 5 into x plus 2. Okay, so now let's see the first term over here. You can see that there is 3x plus 5, 3x plus 5 common, so we can cut that out. 3x plus 5, 3x plus 5 can be cut out. And for here in this part we have x plus 2 common, so we will cut that out. Okay, x plus 2, x plus 2, so we are left with 10x plus 18 is equal to a into x plus 2 plus b into 3x plus 5. Okay, so now we'll take the characteristic value and solve individually for a and b. So let me just write it over here. Take characteristic value. I know this might be an alien term for you. Okay, so let me just explain it to you in a moment. Characteristic value. Okay, so what I mean by characteristic value is, just look at this part over here. At this part we can see that the a has the denominator 3x plus 5 and b has the denominator x plus 2. Okay, or we could look at over here as well. Okay, so for a, first let's do it for a. Like I'm calculating the value of a. For a, what we will do is 3x plus 5 is equal to 0. Okay, what are we putting to 0? The original denominator. The original denominator, we put that equal to 0, and putting a denominator equal to 0 is known as the characteristic value. Okay, putting denominator equal to 0, and then x would come out to be x is equal to minus 5 over 3, and this minus 5 over 3 is the characteristic value of a, okay, of this fraction. Okay, so when we put the factor, the denominator equal to 0, that way we can calculate the characteristic value. Okay, so the characteristic value come out to be minus 5 over 3. Okay, so now what we will do is that we will put this minus 5 over 3 in this equation over here. Okay, so let me just write it out again. 10x plus 18 is equal to a into x plus 2 plus b into 3x plus 5. Okay, so as we have put 3x plus 5 is equal to 0, we can just see 3x plus 5 is equal to 0, and 3x plus 5 is over here as well. So when we put that equal to 0, we can just replace that 3 with 0. We don't have to put the characteristic value, because if we put the characteristic value, if we put minus 5 over 3 in place of x, then also we will get 0. So let's just directly put 0. Okay, and then over here we will have minus 5 over 3 plus 2 times a, and then over here we also have 10 minus 5 over 3 plus 18 is equal to this. Okay, so if we divide 4 over 3 by 1 over 3, we get 4. So a would be equal to 4. Okay, then for b, what we will do is we'll follow the similar steps. We'll just write for b over here, and then we would this time put x plus 2 the over here equal to 0. Okay, x plus 2 is equal to 0, and x is equal to minus 2, and that way the value of b would be 10 times minus 2 plus 18. Okay, minus 2 is equal to, we will put the a, this factor of a equal to 0, because that is we're solving for b, and that will naturally come 0. So 3 times minus 2 plus 5, and that is minus 1. So that will be minus 1b. Okay, so b is equal to minus 2 divided by minus 1, and that is 2. Okay, in partial fractions form we can represent the fraction as, wait, let me just go back to the question. Okay, here is our question. So we represented it as in form of this form, right, a and b. So we can represent it as 4 over 3x plus 5 plus 2 over x plus 2. Okay, now we can counter check over here, and we can see that this is equal to this, so which means our working is correct. So these are the three basic steps to convert a fraction into a partial fraction.